Hey there, glad to be here with you today. This video is the second of a 5 series where I will review 5 handheld oscilloscopes with a bandwidth equal or over 100 MHz and the price range from 50 to 100 euros. That will be in US bucks something like $52 to $104. And for my friends around the world, you have here on the screen some more currencies for better reference. So the tonight guest is also from FNIRSI. I'm talking about the 1C15 Plus. And I decided to make the review of this device just after my last week review of the FNIRSI 5012H, so you can have already a better perspective of the differences in both devices. Before moving on, let me tell you that this video is not sponsored and I bought this device with the affiliate money I got from you guys that use the affiliate access links. You have them here on the screen, and if you want to help the channel, please use these links whenever you want to buy something on AliExpress, Amazon or Banggood. The price will be the same to you. No extra costs, but it will help me with the channel, and this help is much appreciated. Thank you guys. Back to the 1C15 Plus is a 110 MHz oscilloscope with a sampling rate of 550 millisamples per second. It's not so compact as the 5012H, but just from the first look and even without starting it, I can see here serious advantages. So without further ado, let's start this by viewing the feature highlights. Okay, so first things first, and as always, I'm going to show you how this was delivered and what came in the box. This was delivered packed like this. I already opened because I have to make sure that it has battery for recording this. It came on a box and with this protection, extracted bag, and also this little bag to protect this carrying bag when it comes. Well, this carry bag is well, it's very nice. It's similar, it's equal to the one that is delivered also with the 5012. Well, in the bag we have the normal FNIRSI user manual. This is the old format. Right now I know that they have some new manuals that are much better than this, more organized with infographics and stuff like that. So we have a manual. We have also a micro USB to USB Type A cable, the quality assurance certificate or something like that. We have a BNC to alligator clips cable, and also a power supply. Yeah, it's not one of those power supplies very good, but it's included. It's nice to be included. We have the normal P6100 probe, and should be enough for this. And finally, let me put all the stuff back here, and finally we have the oscilloscope. Okay, so the oscilloscope comes also in this protective bag. Very nice. At first sight, I already noticed some things that are evolution from the 5012H or 5012H. It keeps having this rubber anti-slip protection. Also this stand for working on vertical position. The plastic, it's much more plasticky, or it's like a more breakable plastic. To be honest, I think the other one, it's Well, it's a different kind of plastic, not so breakable, but this cover gives it good protection, and it's anti-slip. It protects from slipping the oscilloscope. What I want to tell you, and for the first impressions that I notice right away, is that you have here a square wave output for probe calibration, and the 5012 doesn't have this. The charging is made on the top, not on the bottom. So another thing that I think it makes this not so compact, but it makes better when using, is this BNC plug to be completely out. And that is important, for example, for using a termination like this. This is a load resistor 50 ohms, and it has a large connector. So yeah, in this one I cannot use it, I cannot fixate it up to the end, to be honest. I think I have to take this out, even so, to be able to, to be able to use this all the way down. I have to take the cover, even so. But on the 5012H, it's completely impossible to use something like this. The probe is also a little bit hard to rotate, well, to plug it and rotate on the other one. Well, with this one it's a little bit more easier, but even so it's not perfect. Okay, so first impressions that I noticed already, as I told you, it has a square wave output for probe compensation, and something so simple as the light showing you when it's charging. On the other one, you don't have any kind of light, and this is a nice detail to know when it's charging. Regarding the keys, you have also the normal auto, stop, menu, and OK for selection. You have this joystick also for selection and for moving. You have the measurement key, the 1 and 100 key, and AC/DC. Also voltage and millivoltage. You have here the second and nanosecond selector. 50% reference. I don't know what is reference. I will see more ahead to see what it does. Single for saving the waveforms in memory, and the selection. I don't know also what this does. I will show you in a bit. So that's it for first impressions. Okay, I have here the oscilloscope ready for testing. I already connected in the BNC my Owen X DG2100 function generator. As if you follow the channel, you know that it can go up to 100 megahertz, so I can full test this at 100 megahertz. Okay, let's start this and see what we have here. Okay, and something is missing. Let me take this out. Whoop. Whoa, this didn't went. Okay, so after this small fight with the protective plastic or cover here of the display, I already connected the function generator and turned the channel on. So we have right here a sine wave. It's a 1 megahertz sine wave with an amplitude of 1 volt peak to peak. It says 2, but I think this might be something on my function generator. Okay, so the display itself, it's self-explanatory. We have here the trigger modes, auto, normal, or single. We have here the selection mode. If we press the select key, it will turn this arrow for selecting the offset of the trigger. And you use this joystick, this small joystick, this knob, to control it. If you press it again, it will allow you to select the offset of the signal altogether. Okay, so I'm going to start explaining this. We have here the 50%. It will allow you to set the offset of the trigger of the signal and something else, or all of them together. Just select it, OK, and it will center everything in the screen. As you saw, the auto function also works OK. Let me just increase here the time. In terms of buttons, we have, as you saw, the OK for selection. We have the menu and the stop, also the auto. The measure will open a small information window or something like that with all the available measures, all of them at the same time. But we can have also some other in the end. I will show you how. We have the 1, 10, and 10 times button to say if the probe is 1 time or 10 times. Right now it's 1 time because it's a direct cable to the function generator. And we have also the AC/DC here that will change on the display over there. So you have here to decrease or increase the amplitude or the voltage, as you can see, 1 volt, 500 millivolts, 200 millivolts. You can change it like this, and you can change the time divisions with these 2 buttons. Okay, you have here the information. Okay, using the select I already show you, you can change this. You have also the save button to save the waveform to the memory. If you press it for a while, you have access to the already saved waveforms. And okay, and you have here the trigger mode, the single. Let's do auto and put this again in auto. The stop and the menu. As you can see, the keys here are pretty intuitive, other than this area that should be redone. Most of the stuff it's pretty obvious. We have here in a menu. When you press menu, it opens this small menu. To work with the menu, you use the up and down of the joystick to change, and right and left to change the cursor inside the window. So for example, if I want to put this in AC, I just move the cursor there and press OK. As you see, it changed here. Obviously, I can do the same here. It will change the option, but it will not update here, so it's a bug. Okay, so when pressing this, it should update the menu. Okay, it's not very important. You have also here the 1 times 1 or times 10 for the probe compensation. This is the measurement menu, and those measures appear in the end. We have this one that will show everything on the left, but you can also have some measurements that you want here in the bottom. For that, you just move to the desired measurement and press OK to activate here the measurement. Quite simple. You have also the display menu where you can, for example, use the persist option. I had this in 1 second. You have 1 second and infinity. To show you the persist option, if you don't know, this is on the 5012H, the afterglow option. So I will turn the sweep on. Let me do an auto. First, let's take the menu out. Okay, so we have here, and you can see the persist showing on the screen. Let me just put the persist in infinite, and that will be a mess on the screen because it will overwrite everything. This is the infinite, and without the persist. Yeah. Okay. We have also the roll on and off, so you can have the signal rolling on the display for lower time divisions. This is the trigger menu. You have the auto normal modes, also the single, and you can select here the rise or fall for the edge. Then you have a menu also for calibration. It takes about a minute to calibrate. And the last one is for the desired language. It can be Chinese or English, preferably. So quite simple to operate, to be honest. For example, if you want to move the offset, it's quite fast to respond. Up and down shows the change the offset, and right and left you can change the position in memory using the memory depth. So yeah, quite simple to use. And lately I forgot to tell you, we have obviously here the indication for battery, and this is the position in memory that you are right now. Okay, 50%. Everything goes to the center. Yeah, I think it's quite easy to work. Let's put some bandwidth on this and test the real bandwidth also of the device using the -3 dB voltage to see what is the real bandwidth of this device. So for testing bandwidth, and before going to test the real bandwidth of the device, I used a 50 ohm terminator, and the device, my function generator, is also configured for a 50 ohms output. Let me put this in the center and let's start testing. Okay, so let's do auto. Right now we have 1 megahertz with a VPP about 1 millivolt, about 1 volt almost. Duty cycle 50%, so it's perfect. Let's start to increasing this to 10. Okay, so we have 10 megahertz. Let's do auto again. With 10 megahertz, we have a VPP of 984. It identifies 10 megahertz. Duty cycle 50% also. Let's take this to 25 megahertz. Okay. At 25 megahertz, we still have a VPP. Let me do an auto again. We have a VPP of 1 volt, so quite good. We have the frequency at 25 megahertz, and yeah, also the duty cycle 50%, so it's okay. Let's move on this to 50 megahertz. Okay, we have it at 50 megahertz. Let me do auto set. Well, at 50 megahertz we have a sine wave that starts to, well, to show some problems. It identifies 50 megahertz, and we still have a VPP of 800 more or less millivolts. Yeah, so this is 50 megahertz. Right now I'm gonna take it to 75. Okay, in 75 megahertz we have a really big drop. Let me do an auto set just in case. Yeah, we have a really big drop in millivolts. It's about 450 millivolts, way lower than the 700 it should be. And 75 megahertz, still a duty cycle of somehow around 50%. Let's take it all the way to 100. Yeah, 100 megahertz. With 100 megahertz, you have identifying almost, yeah, 100 megahertz. Let me do an auto set. Yeah. So we have 250 more or less millivolts in peak to peak. It should be something between 700 and 1 volt. And yeah, the duty cycle is still okay. So what does this mean? Let me show you. the minus 3 dB should be around the 700 millivolts, and I will take the bandwidth up to that voltage to see what is the real bandwidth of this device. When this value comes near 707, between 700 and 707, we should have the real bandwidth of this device. Let me take it a little further. Okay, so yeah, we are in the 700s, 53 megahertz. Let me fine tune this, like 54. Yeah, 54, 55, no, 54. Yeah, this is something like 53 something. Yeah, I think we are there. 712. It's changing, but yeah, mostly we are almost there. So I should say this probably is a 50 megahertz oscilloscope, not really the 110 that is there, but even so, it's much better in terms of bandwidth support than the 512H. And when I say it's much better, I say it's 5 times better than the other one. So even so, for the price, well, for I think this was about 65 euros or something like that. I don't know. I will show you in the end, in the conclusion, the price. But for the price of this 50 megahertz oscilloscope, yeah, it's not bad. It should be 110, but yeah, it is what it is. And yeah, okay, let's see where I can take this to be with a more accurate sine wave. The sine wave will start to look like a sine wave at 15 megahertz, more or less. Even if this oscilloscope is in every way better than the 5012H, one of the things that I have to say it's not so good, it's the stability of the signal. As you can see, the signal shakes a lot, and in the other one, it's the only thing that is better is the stability of the signal of the line that is drawn on the screen. But other than that, this one passes the other one in everything. So yeah, let me try to take this to 30 megahertz and see if we can have a decent sine wave. Open a bit of signal. No, we cannot open more than this, so yeah. I think that 15 to 20, it's the, well, to have this well drawn in the screen, it's the desired voltage, even if he works up to 50 something with correct values. Yeah, okay, in terms of bandwidth, that's it. Let me just draw here a square wave. My function generator only supports square waves up to 30 megahertz, but in square waves you cannot be so demanding. So let's do here something like 1 megahertz square wave. Reduce the timestamp. Yeah, 1 megahertz, you can see it's pretty decent. Let me increase this up to, yeah, right now we are up to 6 megahertz. Well, until 5 megahertz you can have almost a decent sine wave. Yeah. And a triangle wave with 3 megahertz. Yeah. And the peak to peak, it's okay. Regarding the bandwidth, one last thing I like to do, and since my function generator supports, I like to print here a little graphic. Right now I have the function generator with 1 kilohertz 1 volt VPP, and let's try to see if he can draw the little heart. Yeah, it seems okay. And I will show you the importance of the megasamples per second. This is with 1 kappa hertz. I will increase this to 100 kappa hertz. Okay, let's do auto. Well, it still is able to do the figure. Just need to set this up, yeah, a little smaller, and as you can see, the speeds, the increase of bandwidth will now starting to make the draw with some failures around it. It has missing pieces, and if you go all the way up to 1 megahertz, it still is able to do it. Let me see. Let me just try to, yeah, okay. As you can see, the draw is smaller, and you have a lot of failures in the middle, missing parts, because the sampling rate was not able to capture all the information needed to make this at this speed. It's too much information for it. But anyway, if we go back to 1 kappa hertz, and again auto, yeah, we can have a well-drawn arbitrary waveform. So yeah, for the price we cannot demand more than this, to be honest. I think that it's more or less tested in terms of bandwidth. Let's see how it handles in terms of identifying the correct voltage. Okay, so for the voltage testing, I will use my millivoltage reference board. I used PCBWay to manufacture a professional this board. They are the sponsors of this video and are currently commemorating their 8th anniversary with several promotions. Visit them to have awesome promotions like manufacturing 10 boards for $5. You have below also the TechCornerTV link that gives you a $5 discount on your first purchase. And I went here to the user manual to see that the vertical sensitivity is 20 millivolts per division up to 100 volts per division. So I don't expect to see it recognize my 10 millivolts first value, but it should work with the 25 millivolts. Let's connect and see what happens. Okay, starting with 10 millivolts. Okay, 10 millivolts, it has a mean between 9, 8, 10. Yeah, it's there. RMS 10 millivolts. So quite happy with this. A maximum of 20. Yeah, minimum also. Amplitudes. Yeah. So, but the first two values seem to be on the spot. Let's move this to 25 millivolts, and also in 25 millivolts it's exactly on the same voltage, so it seems to be quite accurate. I did an auto and changed a little of the value, but yeah, it seems to be quite accurate in terms of voltage, millivoltage identification. Let's go to 50 volts. And in terms of 50 volts, it detects 48.9, 49.4 RMS, and mean the maximum is 50.4. So I still accept this as, yeah, quite near to the desired value. Let me put this in 100 millivolts. It's, yeah, 97. 98, 98, 97. Yeah, it's a little bit off because the value that comes out of here it's 99.98, but not something serious. Okay, it's good for me. Let's go again and try the 250 volts. This one outputs 248 millivolts. So yeah, 244, a maximum of 252. Yeah, acceptable. To be honest, I'm quite impressed with this. 500 volts, 500 millivolts. We do auto, 485. Yeah, it's more or less around that. Okay, it's a little bit off, not too much. 1 volt. And this is 900 and something, almost 1 volt. It's not exactly 1 volt. So this is almost there also. 2.5 volts. Let's see what it says. 245. Yes, it's always a bit off, but not too much. I think it's okay. And this one should be 5 volts, but it's 4 and something, like 3 and 4 and something. And it has a sine wave in here. Yeah. So this is 4.6, something like that. Okay, so it went well. To be honest, I'm quite impressed with this. Much better than the 5012H. I'm going to open this and see how it is inside. Okay, here we have it. Let me just disconnect the battery. It has no marking. They say it's a 3000 milliamps battery. Okay, let's put it here, and here it is. I already have here the board ready for some inspection. Let's start by this corner, and we have here a windbound 32 megabit SPI flash memory. On the left we have a 74 HC 138D. That's a 3 to 8 line decoder multiplexer, this one. So let's move on, and here on the top, that's it. I don't see here in this zone. I believe it must be below this heatsink, the controller for the battery. So yeah, I don't see it here. Okay, moving on. So below we have the GigaDevice ARM GD32F103 VAT6 processor. This is a 32-bit general purpose microcontroller from ARM. It's a Cortex M3. So in terms of frequency, it has 108 megahertz. It's a little bit weaker than the M4 200 megahertz of the 5012H oscilloscope, the predecessor of this. But since we have in here the Altera Max 2 EPM 240T, and both processors are connected to the ADC MXT 2088. This is a dual channel 8-bit 100 MSPS ADC. It says each channel can work independently, and yeah, I think it's used in a lot of devices. In terms of processor, this is a weaker one than the 5012H, but we have two, and you can see by the traces there that they are both connected to the ADC. So in this corner we have the ES61LV128 16L 10LTL. This is a 128K high-speed CMOS with static RAM. Okay, and let me check what else do we have here. Okay, we have a Texas Instrument op amp, the 695. And below we have the 74HC 405, 4051D. This is the 8-channel analog multiplexer demultiplexer. And what else? And in here we have the Y240S. This is a high voltage photo MOS relay, also used in the FNIRSI 512H. And yeah, I think that's it. We have the relay in here also. And let me see if I'm missing something, because on the last review I missed the ADC. Sorry guys for that. But I think that's it. The main components are these ones. I think that we are okay. Let me close this and wrap this up. To wrap this up, let's start with the price. For this unit, I paid €57.18 at August 2022 exchange rate. That is something like $58 or £48. I bought all the 5 oscilloscopes during some AliExpress promotion season and got 2 discounts that are already included in the price, so without those discounts should cost around €65. I don't want to dig too much in comparisons because I will do a showdown video between all these oscilloscopes in the end of this 5-video series, but this oscilloscope is better in almost every aspect than the 5012H, and let's recap why. It has a square wave output for probe compensation. The BNC connector is more exposed, that will make easy to connect the probe or the cable or even a terminator. This one seems quite obvious, but the 5012H didn't have, and I'm talking about a LED that indicates if the oscilloscope is charging. You have some shortcut keys that will ease up your life while using the oscilloscope, and those are observations only on the outside. In terms of performance, it isn't a 110 MHz oscilloscope, not even a 70 MHz oscilloscope. If you stretch it to the max, you can work it with more or less, up to approximately 50 MHz, but that's stretching a bit. In terms of accuracy for voltage detection, I was quite surprised with the results. Even if the documentation clearly stating that it can identify signals from 20 mV to 100 volts, it was able to detect the 10 mV signal from my millivolt reference board, and all the voltage up to 5 volts range without much problems. It had some small deviations, but pretty near from the values I get while using a multimeter. So, should you buy this? As always, it depends. Now that you know that you are not buying a 50 MHz oscilloscope, this is a pretty nice device if you need an oscilloscope for your DIY projects. You will have an oscilloscope that operates in a megahertz range in an acceptable way up to 50 MHz and for a pretty accessible cost. For me, this will be a better buy than the 5012H, and if I wanted an oscilloscope only for my electronics projects, I will surely buy it. For professional utilization, maybe it will be a bit stretch, but it depends always on what you'll do with it. So don't forget that you can help the channel if you want to buy one, just by using the access links on AliExpress, Amazon or Banggood. The price will be the same to you, but you will help a lot the channel. Thank you for your help, it's really appreciated. If this video was in any way useful to you, please don't forget to slap that like button, and if you haven't already, please subscribe and hit that bell to be the first one to be notified whenever I upload a new video. That's it for today. I hope to see you in my next video. Until then, stay safe. Cheers.